Hi, this is JD from Techcanvass, and in this video, we will talk about critical path method in project management. But before that, let us understand what a schedule network diagram is. In a project, a schedule network diagram is a tool that shows the order in which project activities are scheduled in order to achieve the goal of the project. This diagram is a representation of project schedule in a graphical manner. It is a combination of boxes and arrows usually drawn from left to right. Here, the boxes are referred to as activity nodes. Once the project schedule network diagram is completed for the project, you will end up having begin and end dates for every activity from start of the project to the end of the project. Various project activities will be sequenced and completed in an order which is based on the relationship between those activities. But what is the critical path? The critical path in project management is the longest possible sequence of activities that must be completed to successfully deliver a project. The activities on the critical path are typically known as critical activities because if they get delayed, the whole project gets delayed. Therefore, by finding the critical path, you can also determine the actual duration of the project. Now let us take an example set of activities and try to determine the critical path for the network diagram. From this table of activities, we can not only see each activity with their duration in days, but also the dependency of each activity on the other. The next logical step is using these relationships to draw the project network diagram. You can verify this diagram against the table. Keep in mind that this is the most basic version of network diagram. It does not include any activity attribute like early start, early finish, late start, and late finish. We'll come to that soon. Once you are done with the network diagram, you will see the diagram also has all activity paths from start until the end of the project. We will go over these paths one by one to identify the critical path of the project. So, what are the possible paths from start to end of the given diagram? We have one possible path, ABDGH, and the sum of the days comes to 3 plus 4 plus 5 plus 4 plus 3. It's 19 days. We have another possible path, ACEGH. The total number of days comes to 3 plus 2 plus 1 plus 4 plus 3. It's 13 days. We have one more possible path, ACFH. The total number of days comes to 3 plus 2 plus 2 plus 3. 10 days. It is clear here that out of the three possible paths, from the start of the schedule network diagram till the end, the longest path is the path number 1, ABDGH, 19 days. Therefore, path number 1 is a critical path of this network diagram, which means this is also the project duration. Now that we have an understanding of what a critical path is, let us try to understand more advanced factors involved in the process. Early start. It is the earliest possible time that an activity can be started at a project. Latest start. It is the latest possible time that an activity can be started in the project. Early finish. It is the earliest possible time that an activity can be finished in the project. Latest finish. It is the latest possible time that an activity can be finished in the project. These activities are denoted in an activity node like below. Early start and early finish are calculated using a technique called forward pass. The formula for early finish is early start plus duration of the activity. The formula for early start is largest early finish of preceding activities. Note, first node of the sequence diagram has an early start value of 0. Now, let us calculate the forward pass for this diagram. We have the nodes, we have the duration, and we have the sequencing done as per the relationship. Let us start with activity A. As you know, the first node in the sequence diagram has an early start of 0. 0 plus the duration gives you an early finish of 3. Let's continue with B. The early start of this activity is the early finish of the predecessor activity, which is 3, plus the duration gives you the early finish 7. Likewise for C, the early start of 3 plus the duration gives you early finish of 5. For D, early start of 7, early finish of 12. For E, the early start of 5, early finish of 6. For G, the early start of 12, early finish of 16. For F, the early start of 5 and early finish of 7. And for H, it has two predecessors like G. And which early finish should it take for early start? The answer is you should take the greatest number, and in this case the greatest early finish is 16. Hence the early start of H is 16 and the early finish is 19. Backward pass. Late start and late finish are calculated using backward pass. The formula are late start is equal to late finish minus duration of the activity. Late finish is equal to smallest late start of the succeeding activities. Now let us use backward pass for the same example to calculate the late start and late finish. We'll start with activity H. The late finish of H is 19. Remember, the late finish and the early finish of the last node in the sequence diagram is always the project duration. Now, the late start for activity H is late finish minus the duration, which is 16. Now for activity F, the late finish is 16 minus the duration, you get the late start of 14. For activity G, the late finish is 16 minus duration of 4 gives you a late start of 12. For activity E, late finish is 12 and the late start is 11. For D, the late finish is 12 and the late start of 7. For C, the late finish is 11 and the late start of 9. Now for C, you have two successors, and which one of the late starts of these successors will you take it as a late finish for the current activity? The answer is exactly reverse of what you did in forward pass. Here you take the minimum of the late starts to assign as the late finish of the current activity. For activity B, the late finish of 7 and the late start of 3. Finally, for activity A, you have a late finish of 3 and late start of 0. Now that we understood early start, early finish, late start and late finish, let us look at what a float is. The float is also known as a slack. It is the amount of duration that an activity can be delayed without causing any delays at the project level or in any other succeeding activities. There are two major types of floats: total float and free float. Now, what is a total float? The duration of time of an activity that can be delayed by the team without delaying the project's final end date. It is called total float. You would have guessed by now that critical path activities will have a total float of 0, as it is the longest possible path in the project. The formula for total float is late finish minus early finish or late start minus early start. Now using this formula, let's try to calculate total float in our example. As you can see, the formula for a total float is late finish minus early finish or late start minus early start. For activity A, the total float is 0 since 3 minus 3 is 0 or 0 minus 0 is 0. For activity B, it's the same result. For activity C, late finish minus early finish and late start minus early start both equals to 6. For activity D, the float is 0. For activity E, the total float is 6. For activity F, the total float is 9. For activity G, the total float is 0. And for activity H, the total float is 0. As you can see, the total float for all the activities in the critical path are 0. Free float. Now, let us look at free float. A free float is the duration of time an activity can be delayed by the team without delaying the early start of a succeeding activity. Similar to total float, all the activities in the critical path will have a float of 0 for the same reasons explained above. Now, what is the formula for free float? A free float can be calculated by minimum of early start of successors minus early start of activity minus duration of activity. Now, let us try to calculate free float for all the activities in our example. The formula for free float is minimum of early start of successors minus early start of the current activity minus duration of the current activity. Let's take an example. Activity A has two successors. Both of them have an equal early start of 3. So the formula for free float for activity A is minimum of early start, that is 3, minus early start of the activity is 0 minus the duration, which is 3. 3 minus 0 is 0. Now for activity B, early start of the successor is 7 minus early start of the current activity 3 minus duration 4 is 7 minus 3 minus 4 of 0. For activity C, you get an answer of 0. For activity D, you get an answer of 0. For activity E, you get 6. For F, it is 9. For G, it is 0. And for H, it is 0. Now, you would have noticed by now that free float for all activities across the critical path is 0, similar to total float. Now, keep in mind that a project can have more than one critical path. Several critical paths means that the project has high risk. Also, the critical path of the project can change over a period of time. We hope you found this video useful. Please subscribe to learn more. Thank you.